All right. So next, we're going to talk about the most common form of linear equations. There are a couple other forms, but those are going to be talked about in video 1.1b. And so the most common form of linear equations that we'll see in class is called slope-intercept form. Slope-intercept form. And that's the form that these equations up here are in. It's a nice simplified form where we're left with one x and one y and a slope and then a constant. And so slope-intercept form always looks like this. Y equals mx plus b, where b is the y-intercept, which means that it's the point 0, b on every graph. So no matter what the graph looks like, b in this form will always correspond to the point 0b, and 0b will always be on the line. M, on the other hand, is the slope of the line. So y equals the slope times x plus b. We are going to quickly kind of investigate this, pull out the pieces, and then also graph it over here so you can see how this translates into a graph. So in order to graph this, the first thing I want to do is I want to identify my pieces. It might help to rewrite it. You don't have to do this, but some of you might prefer to rewrite this as negative 2x plus 1, just so you're in the same order as slope-intercept form. Notice that the 1 stays positive, the negative 2 stays negative, and that is going to help me make sure I get the right slope and the right y-intercept. So I'll first pull out my slope. So m in our equation is equal to negative 2, which means, if I remember my rise over run, that I am rising negative 2 and running 1, right? Negative 2 over 1 is negative 2, so I'm going down 2 and over 1. I can also pull out my b, my y-intercept. So b in this equation is equal to 1, which means that the point 0, 1 is the y-intercept. Now to graph this, I'll just show you a quick example before we get into too much detail. I'll start by identifying my y-intercept on the graph. So the point 0, 1, 0, 1, remember my x is horizontal, my y is vertical. And I'll just label this point here so that you all can see it. And then I'm going to use my slope to find another point. So I want to go down 2 as I go over 1. So I'll go down 2 and over 1. And this should be another point on my graph. And I like to usually continue and do a couple more so that I can see my lines start to form. And you can also go backwards. So instead of down 2 over 1, I'll go back 1 and up 2. So doing the opposite. And now I can see more or less that this is going to be my equation, my line. And so this is the line 1 minus 2x. Great. Let's go on to the next part. So turning your paper over, we're going to do a couple examples. So these examples are to help us graph and interpret these slope-intercept forms. So again, we'll start here. I'm going to rewrite this one again just to help my numbers be a little more clear. And I'm going to use colors to help identify those pieces. So y equals 0.5 times x plus my b is positive 5. This gives me a slope of 0.5. I find it really difficult to work with fractional or decimal slopes. And so I usually convert to a fraction. and I would say that m equals 1 over 2. I like this better because now I can see really clearly which number is my rise and which number is my run to help me draw my graph. I'm then going to use this 5 and identify my y-intercept. So we know that b equals 5, which tells me that the point 0, 5 is my y-intercept. Now to graph this, again, I'll start at my y-intercept. That point will always be on my graph. So 0, 5. My y-intercept will always be on this y-axis. And I'll label this point just so you guys can see it. And then I'm going to use my slope to get my next point. So we're going to have to go backwards a lot because we're really at the top here. But my slope is 1/2, meaning I rise 1 as I run 2. I rise 1 as I run 2. So I'll go up 1 and go over 2 to this point. So up 1, over 2. And then I can do the same thing backwards to help me out. So down 1 and over 2 to here. Down 1 more and over 2 to here. And now I've got a couple of different points that I can start to plot. And my line will look like this. All right, let's do this middle one. The next one is y equals 7. This is a little weird because we don't have an x again. So we kind of have essentially a 0 slope. And the way I see that 0 slope is I might rewrite this to be y equals 0x plus 7. And I can see now that my m is equal to 0. There isn't an x. There is no coefficient there. It's a 0 coefficient. And if you remember what 0 means, 0 always means that we're going to have a horizontal line. So the question is, where is my horizontal line? And we can actually still use our b equals 7 to tell us that our horizontal line has a y-intercept at the point 0, 7. And so even though I don't have an x in my equation to begin with, I can still kind of use my m and my b to help me understand it. So down here on the graph, I'll start with my point 0, 7. Again, it's off the graph. Oh no, these are my mistakes the first time I make notes. I'll do better next time. So we'll call it 0, 7. And then we know we have a horizontal line with no slope. So we can go straight across for a horizontal line. The third one is over here. This one has been written in a way that makes it really hard to identify what is going on. So we are going to be rewriting this to help us see it in slope-intercept form. So this is going to take some rewriting, but our goal, I'll put it up here, our goal is we want to end up with y equals mx plus b. So my main goal here is to isolate y. And what that means is I want to get this y by itself so that my equation mirrors our slope-intercept form a little better. All right, to do that, I'm going to start by rewriting my equation, 3x plus 2y equals 12, and then subtracting 3x from each side. Now I've got 2y is 12 minus 3x. And then I have to divide by 2 to make sure my y is isolated. 12 divided by 2 is 6. Minus 3 divided by 2, I'm going to leave it as a fraction, x. And now I can identify that my slope here is -3/2. And my y-intercept is 6, meaning I have the point 0, 6 on my graph. To graph this, again, we'll start with the point 0, 6, our y-intercept. I'll put that here. And now we're going to use our slope. So this fractional slope is a little different to graph. Remember, we have rise and run. And so I'm going to rise -3. So I'm actually going down 3 and then running 2. 1, 2. So this is my next point. We'll go down 3 and over 2. I'll do the same thing again to help me get to my next point. Down 3 and over 2. And I can now see my line. Perfect. The last piece of information for this section is just that we remember how parallel and perpendicular lines work. Two lines are parallel if their slopes are equal. If their slopes are equal. And so what that looks like is in these equations, the equation of this line is y is 1/3 x plus 4, and the equation of this line is y equals 1/3 x minus 1. And if they're parallel, which they are, meaning they never cross or touch, we should always have our slopes being equal. So our m in our y equals mx plus b, those will be equal. On the other side, though, two lines are perpendicular if their slopes are opposite reciprocals. And what that means, I'll just give you some examples. I'll do it red down here. So an example, if the number is 2, its opposite reciprocal is opposite first. So 2 over 1 becomes 1 over 2. And then we have the opposite, taking it negative. So if the number is 1/3, the opposite reciprocal is you flip it. That's the reciprocal part. So we'll make it 3 over 1 or 3, and then make it the opposite, so negative. So last one, I'll just say if we have -5/12, the opposite reciprocal would be the reciprocal, which is 12 over 5, and the opposite, which is positive. So what that looks like in equations, over here, this is the same line as above. It's 1/3 x minus 1. And this line is perpendicular, meaning there's a 90-degree angle. And the equation of this line is y equals -3x plus 4. And so you can see that 1/3 and -3 are opposite reciprocals. All right, that's it for 1.1a.